Welcome to your first installment of the Top 10. You'll see these 2 or 3 times a week. The first couple, you'll just copy my work exactly, and after that, I'll ask you to apply those principles to some new problems. Important thing to pay attention to when you're working these Top 10s is that we do not skip steps. We do not take shortcuts. We do not use some other method. We do them my way. It may or may not be what you saw in high school. Do them my way. The final answer is not the final answer, but the entire process. Okay, so we're going to start with the idea. The first college level idea we're going to introduce is rational exponents. That's radicals written as fractions, exponents that are fractions. Now, think of a tree. Where are the roots? At the bottom. So any roots we're going to write at the bottom of our fraction. Any roots we're going to write at the bottom of our fraction. We're going to write that as 243 to the 1 over 5 power. X to the 2 over 5 power. Now, this x is not inside my radical, so it doesn't have an over 5 power. That's just x to the negative 3 over 1. Now we're going to find a common denominator, which is 5. I'm going to write that as 243 to the 1 over 5, x to the 2 over 5, and x to the negative 3 over 1 times 5 times 5, which is going to give me 243 to the 1 over 5. You can go ahead and simplify that using the sheet I've attached to be 3. X to the 2/5, x to the negative 15/5. So my final answer is 3. Remember, when you're adding fractions, you add with the common denominator, x to the negative 13. I sent you an attachment showing different powers, and so if you look on that sheet, you'll find that 243 is 3 to the 5th power. Okay, factoring. I want you to do factoring my way. We're going to start by using an idea you learned in 3rd or 4th grade. We want to find two numbers that multiply, or maybe 6th grade, whenever you start to do this, to find the first and the last, which is 70x squared. Now, because that's a positive 70x squared, that tells me they're going to have the same signs. It's important that you write that down. If that were a negative 70, I would know they had different signs. And they have to add to give you the middle. So we want things that multiply to give me the first times the last, and add with respect to signs to give me the middle. And these have to have the same signs. And if you play around with it for a while, eventually you'll come up with 70 is 14x times 5x, but that would give me a positive 19, wouldn't it? Let's make that a negative 14 and a negative 5. All right. So now, I know my factors are, my top wave here, and this is important, is negative 14x, and my bottom wave is negative 5x. I'm going to require that you show me that top wave and that bottom wave and what the values are. And I'm going to find this first term right here by realizing that it's a factor of that and a factor of that. So I'm going to look for the greatest common factor of the first term and the first term, remembering that greatest will always be positive. And the greatest common factor of 10x squared and negative 14x is 2x. So that's what I'm going to put right there. Now, 2 divides into 10, 5x times, and 2x divides into negative 14x minus 7 times. And you can see that that 2x times that minus 7 gives you the negative 14x that you're supposed to have. And now we have to stop and think, well, if that's negative 5x and that's a 5x, that's got to be a negative 1 to multiply to give me negative 5x. Now that's factored. The problem says equal 0. So I'm going to write each of those factors equals 0, because the only way to multiply and get 0 is if one of the factors equals 0. In solving that equation, I have x is positive 1/2 and positive 7/5. So all that's important. This part up here is especially important. This part over here is important. This part over here is important. This part here is important. This part here is important. This part here is important. It's all important. Don't skip steps. Don't take shortcuts. Don't use some other method. Do them my way. Well, come on. Cramer's rule. Many of you learned how to solve these in high school by eliminating, manipulating them so that one of the variables disappeared. Or perhaps you might have done something like this and said 2x equals positive 3y plus 1 and dividing by 2 and go back and substituting that into x and solving for y. You can do that. That's a lot of work. We're in college now. We're going to learn a new method called Cramer's rule. And Cramer's rule allows us to find a solution using a matrix. So I want you to write all the coefficients, 2, 1, negative 3, 2. Draw a line for the equal sign, negative 1, and negative 4. Make sure you see where those came from. I just took the variables out and put a line for the equal sign. We're going to evaluate a 2 by 2 matrix. I'm going to write 3 matrices. That's the plural of matrix. I'm going to write 2, 1, negative 3, 2. 2, 1, negative 3, 2. Then I'm going to put these two in the x column. And I'm going to write negative 1, negative 4, negative 3, 2. And that came by putting these two in the x column. And finally, I'm going to write another matrix by putting these two in the y column. And that's going to give me 2, 1, negative 1, negative 4. Make sure you see where all those came from. I simply put these two in the y column and got that. Now, I'm going to evaluate these matrices by multiplying that times that minus that times that, which is 7. By multiplying that times that minus that times that, which is positive 12, and that gives me negative 14. That times that, negative 8, minus that times that, negative 1, which is negative 7. Now, I got this one by replacing the x numbers with that. I got this one by replacing the y numbers with that. And I got this first one without replacing anything. So I'm going to call this d sub x, and d sub y. And it turns out Cramer's rule tells us that x is d sub x over d. X is negative 14 over 7 equals negative 2. And that y is d sub y over d. Y is d sub y over d. Y is negative 7 over 7, which is negative 1. So my solution is -2, -1. It's an ordered pair. It's a point on the number line. Let's erase that and do all that again. I got kind of sloppy there. All right. Let's do it this way. I want you to do it this way. I want you to write that as 2, 1, -3, 2, -1, -4. And I want to find D equals, D sub X equals, and D sub Y equals. And for D, I'm not going to make any replacements. I'm going to write these first set just like they are. 2, 1, -3, 2. And I'm going to multiply down to the right, minus down to the left, which is 7. For D sub X, I'm going to put these numbers in the X column. And that's going to give me -1, -4, -3, 2. Once again, I put these numbers in the X column. And I multiply down to the right, and I get -2. Minus down to the left is +12. And -2 minus 12 is -14. And for D sub Y, I'm going to put these in the Y column. So I'm going to get 2, 1, then -1, -4. Again, all I did was put these in the Y column. And I multiply down to the right, I get -8. Minus down to the left is -1. And minus and negative becomes plus, so that's -7. So X is D sub X over D. -14 over 7 is -2. And Y is D sub Y over D. -7 over 7 is -1. Now here's the important part I don't want you to skip. This is a point. These are two lines. And the point where these two lines intersect is the point. -2, -1. Be sure and write that as an ordered pair, as a point. Okay. Don't skip steps. Don't take shortcuts. Don't use some other method. Do these my way. I'm going to ask you to plug these numbers in and to write them vertically. Now, if we had a number, we just plug a number in here. Instead of a number, I'm going to plug a function in. I'm going to write that as 2t plus 5 squared minus 3 times 2t plus 5. Plus 5, and then expand that. You might want to go off to the side somewhere and FOIL that out if you don't know the shortcut. But the shortcut is you're going to have a 4t squared and a 25 on the end. And when you do FOIL, you're going to have a 10 on the out and a 10 on the end, which is going to give you 10t in the middle. If you have to go off to the side and FOIL that out, you can, but that's what you're going to get. Now, -3 times that's going to give me -6t, and I'm going to put those under the t's, and -15. And I have plus 2, that should be a 2 on the end. Adding those up, I get 4t squared plus 4t plus, I believe that's 12. It's very important that you show this little step right here. All I did was plug in 2t plus 5. Everywhere I had an x and write them vertically. Then simplify them and add them down. And I got that. Cross multiplying. Anytime you have two fractions with an equal sign, you can cross multiply. And I'm always going to go top right to bottom left, just kind of like a matrix. 4x minus 7 times 2. equals top right, bottom left. I said it backwards last time. And when I distribute that, I'm going to get 8x minus 14 equals 15x plus 5. And don't forget the equal sign is in the middle. Don't get everything on one side. You want to get your x's on one side, your numbers on the other. You can do it either way. I'm going to do the letters on the left, numbers on the right. And that's going to give me negative 7x equals negative 19, positive 19. Dividing both sides by negative 7, x is negative 19 sevenths. You could do it the other way. You'd have a positive 19, a negative 19 on the left, and positive 7x on the right. It doesn't matter. I do require that you show that you're cross multiplying top left, bottom right, top right, bottom left. All right, for the slope, I'm very, very particular. If you don't do these my way, I'm going to count it wrong. I want you to identify that this is the first x and the first y, and the second x and the second y, and to write the formula, m equals, put them in parentheses, y2 minus y1 over parentheses, x2 minus x1. Don't forget the parentheses, don't skip steps, don't take shortcuts. Write the formula. Identify x1, y1, x2, y2, write the formula. Then let's plug those numbers in. y2 is 4. y1 is 9. x2 is negative 1. x1 is 7. And that is negative 5 over negative 8. Don't leave it like that, because that tells me you don't know, is it positive or is it negative? A negative divided by a negative is positive 5/8. You can leave improper fractions. You can leave it as mixed numbers. You don't even have to simplify. But I will not take negative over negative. I'll just mark the whole thing wrong. That tells me you don't know if negative divided by negative is positive or negative. All right. Solve these my way. What could I square to get 16? Well, there are two things I could square to get 16. One of them is 4, and the other is negative 4. See, anytime I square something, it's going to become positive. So if the thing inside is positive or negative, it's going to give me a positive answer. I'm going to require you to write, to solve a squared, by doing a square root and writing plus/minus above the constant. If you do not write it like that, the square roots and the plus/minus, I'm going to count the problem wrong. Don't skip steps, don't take shortcuts, don't use some other method. All right, so the square and the square root cancel, and I get 2x minus 1 equals positive or negative 4. So let's write that as two equations. 2x minus 1 equals 4, or 2x minus 1 equals negative 4. And solving those equations, you get x is 5/2, or negative 3/2. It's very important that you show the radicals and the plus or minus. When you take a square root, there are two possibilities. That's why that quadratic formula you memorized in high school had plus or minus. Y'all remember that quadratic equation you memorized in high school? Negative b plus or minus the square root of? Because when you take a square root, there could be two possibilities. Now, the thing I'm taking the square root of doesn't have but one possibility. It has to be positive. I can't take a square root of a negative number, so this has only one solution. And if we undid a square with a square root, we undo a square root with a square. And this one does not get plus or minus, because there's only one sign that I can take a square root of. And I'm going to have 1 minus 3x equals 49. Solving that, I have negative 3x equals 48. Dividing by negative 3, I have x is negative 16. And for the last set, look at that sheet I gave you about the exponents and powers and recognize that 32 is 2 to the 5th power to the x power, and that 4 is 2 squared. It's important that you write it that way. Don't write it as 2 to the 5x, write it 2 to the 5th to the x power. Now we can remember our rules for exponents, which tell us that if I'm raising a power to a power, I simply multiply the exponents. And that's going to be my next step. 2 to the 5x equals 2 to the 2. And in an equation, if I have equal bases, that means I must have equal exponents. So from that, 5x equals 2, and dividing by 5, x is 2 fifths. And the last one. You remember the Pythagorean theorem that a squared plus b squared equals c squared? Well, in a circle, c squared is the radius. In a circle, c squared is the radius. And the center is not part of the circle. The center is inside the circle. In fact, the distance of the center from itself is 0. All the points have a distance of the radius, but the center itself has a distance from itself of 0. So we're going to find the center by making each term equal 0. And the radius is going to be the square root of 121. So what's my center? My center is -6, 0, and my radius is 11. Again, don't skip steps. Don't take shortcuts. Don't use some other method. Do these my way. Make sure your paper looks exactly like mine, and if it does, you'll get a free 100. Good luck, and this will be the first installment where you copy my work. We'll have another one where you copy my work, and then after that, you'll be expected to do them on your own. Good luck, and I hope everybody makes 100.